So reminder children, if in case A is equilibrium with B for the reaction. For this reaction, product concentration is increases. Means, so this is more ready to give. In that situation, product concentration is more, means product is more stable than reactant. So that reactivity of, stability of product is directly proportional to concentration of the product, inversely proportional to concentration of reactant. It's clear, children? Okay. If condition, special point, K, C, okay, now is increase, product concentration increase, means product is more stable. Kc value is low, means decrease. Okay. Now, so what will be happening? Reactant concentration is high. Right? Reactant is more stable. Banu, understand the concept?
Understood, sir.
Right. Now, for the example, children, for understanding of this one, I am taking for the example. X plus O2 gives rise to XO. X2 plus O2 gives rise to XO. For this reaction, Kc is 10, means Kc1 I am taking 10. And the reaction X2 plus 2O2. X2 plus 2O2 is equilibrium with 2XO2. For this reaction, Kc2 I am considered that it is 100. Varshit, tell me regarding this equation and this concept, which is more stable? Either XO or XO2?
XO2.
Very good. XO2 is more stable. That it is K1 is less than K2. Okay. Stability of means XO is lesser stable than XO2. Children, concept clear, Nama? Children, concept is clear. Tell me, ma, concept is clear?
Yes, sir.
So I am giving one more question for this, children. I am giving one more question for this one. You have to give the answer. Now, which oxide of nitrogen is more stable? My question. Which oxide of N2 is more stable? Now, I am writing some chemical equations. So for formation of NO2, means N2 plus 2O2, all are gas phase reactions, plus 2O2 is equilibrium with 2NO2. Now for this reaction, K1 is 10 power minus 3. 10 power minus 3. So that second example, formation of N2O. 2N2 plus O2 is equilibrium with 2N2O. This is K2 consider 10 power minus 1. 10 power minus 1. So NO, 2NO.
So can you write it with other colors, sir?
Ma?
Can you write it with other colors, sir?
N2 plus O2. This is a K3 is equal to, okay, 0.5. Now fourth one, this is a 2N2O3. 2N2O3 is equilibrium with 2N2 plus 3O2. This is considered K4 is equal to, okay, 0.025. 0.025. So, okay, which oxide is more stable? You have to give the answer. Arrange them. Second part. Arrange them. Arrange them in a correct order of their stability. Answer fast, quicker all answer naku.
Sir,
N2O3 is
More stable, sir.
greater than NO
N2O3
is greater than
NO, sir.
greater than.
N2O.
Very good. Is greater than
NO2.
10 volt. Very good. Good. Okay. Clear now? Clear. Understand now my concept, Banu?
understood, sir.
Right. Now I am going to the next one, children, to extent of reaction. First one is this is stability. Second application is extent of reaction. To extent of reaction. Some points I am telling to you, children, reminder. So equilibrium may established immediately starting of the reaction may possible. Equilibrium is established at the end of the reaction is also possible. Next, equilibrium is established. Equilibrium is established at a middle of the reaction. Whatever, ఎప్పుడైనా ఈక్విలిబ్రియం ఎస్టాబ్లిష్ అవ్వచ్చు. ఈ ఈక్విలిబ్రియం ఎస్టాబ్లిష్ అయినప్పుడు ఆ రియాక్షన్ సో ఎక్స్టెన్షన్ బిగినింగ్ లో ఉందా, ఎండింగ్ లో ఉందా, హౌ మచ్ రియాక్షన్ ఈజ్ టేక్స్ ప్లేస్, దట్ కెన్ బి ఎక్స్ప్లెయిన్ బై యూజింగ్ దిస్ ఫంక్షన్. నౌ లెట్ మీ కంటిన్యూ. Extent of reaction. Now we know that, okay, ఇక్కడ చూడండి తల్లి, already we know that Kc is equal to active mass of product upon active mass of reactant. It's clear. Active mass of product upon active mass of reactant. Of course, children. Now, extension of reaction, okay, can be, rate of reaction cannot be explained by this one. Only extent of the reaction can explain. Okay. For the example, Kc value higher anukundam nana. Kc value higher ante product concentration higher unte Kc value higher untadi. Means most of the reaction is completed. So Kc value is low, reactant is left more. It's clear. Understand na, Satvika? Satvika?
Yes, sir.
Right, children. Now, what I am taking, children, this is a Kc value, the value of Kc. The value of Kc, the value of Kc is greater. Concentration of product will greater. Concentration of product will greater. If the value of Kc is low or lower, then reactant left more, means reactant concentration is more. Simple. Okay. Reactant concentration is more and konchame reaction jarigindani ardham. Product concentration is more and reaction is ending of the position. It's clear, children. Yes. Concept clear na? Children.
Clear, sir.
Yes, sir.
Right. Right, going to the next. Now, one more example what I am taking, children. For the example, this is the extent of the reaction. It's clear. Okay, I'm leaving this. Right, children. Right. Now, what I'm taking, this is like this. If I am taking, this is the Kc value of Kc. Now, the Kc value may greater or may lower. Its value may expressed in between, generally 10 power minus 3 to 10 cube. 10 power minus 3 to 10 cube. So this is the lower concentration. So in this area, minimize this area towards this one. The reaction is hardly to move. Reaction is hardly to proceed. So at this area, reaction is almost complete. Almost complete. So greater the Kc value, maximum product concentration, maximum reactant concentration. It's clear. At this area, at equilibrium is almost equal concentrations of reactants and product. Children, it's clear now? Clear now?
Clear, sir.
Understand now? If Kc value is maximum, okay, higher value, reaction is almost complete. Kc value is minimum, the reaction is hardly to proceed, then stability of reactant is greater than stability of product. Here, stability of product is greater than stability of reactant. No discussion here enthalpy. Only we are discussing about the stability. ఎంథాల్పీ డజంట్ చేంజ్. ఎప్పుడైనా ఎంథాల్పీ త్రూ అవుట్ ద రియాక్షన్ ఒకటే ఉంటుంది, అది ఏమీ చేంజ్ అవ్వదు. ఇట్ ఈస్ ఎక్స్టెన్సివ్ ప్రాపర్టీ, అది మాస్ వాల్యూమ్ మీద డిపెండ్ అయి ఉంటుంది. వీఆర్ అప్లైయింగ్ ద ఈక్విలిబ్రియం సిస్టమ్. ఓకే, రైట్ చిల్డ్రన్. నౌ I am taking the here 3 different factors. Now one more is there, that children, that it is first let me discuss about the QC, reaction coefficient. QC means reaction quotient. Reaction quotient. It's clear, children. Now what is the reaction quotient here? This is I am taking the generalized equation, that it is x moles of A plus y moles of B is equilibrium with m moles of C and n moles of D. It is clear. Now QC means, QC at any time of the, at any time QC means, okay na, the ratio of products of the ratio of product of active masses of products to reactants at any time of reaction other than equilibrium state. Any type of reaction other than equilibrium state. Means product means it is the product of the active mass of product to reactant. Means active mass of C power m into active mass of D power n upon active mass of A power x, active mass of B power y. We know that, children, case is also is there. Case is also for the same reaction. C power m D power n upon A power x and B power y. So this expression at equilibrium only. This expression is at equilibrium only. At equilibrium only. But this expression is throughout the reaction. Throughout the reaction, other than
equilibrium state.
Other than equilibrium state. It's clear.
Sir,
So,
what is the difference between those two, sir?
this is the difference. This is the difference. If you are expressing the ratio, at equilibrium state only, that is called as a Kc. Other than equilibrium state, any throughout the course of the reaction, you are applying this concentration values, that it is termed as QC. For example, ఒక reaction proceed అవుతుంది అనుకో, A is equilibrium with B అవుతుంది అనుకుందాం నాన్న. ఇది 10 minutes కి, ఫర్ ఎగ్జాంపుల్ 10 minutes టైంలో ఎక్కడుంది నాన్న, ఈక్విలిబ్రియం ని రీచ్ అయింది. ఇది ఈక్విలిబ్రియం ఎస్టాబ్లిష్ అవ్వాలంటే ఎక్కడ 10 minutes కి ఈక్విలిబ్రియం ని ఎస్టాబ్లిష్ అవుతుంది. అంటే 10 minutes లో ఉండేది ఇది. ఓకేనా? అదర్ దాన్ 10 minutes, అంటే ఈ 10 minutes అంటే 1 minute నుంచి 9 minutes, మోర్ దాన్ 9 minutes వరకు ఎవరు ఉంటారు? QC ఉంటుంది. అండర్స్టాండ్ కాన్సెప్ట్? Only at equilibrium state we are applying the Kc value. Other than equilibrium, అంటే రియాక్షన్ స్టార్ట్ అవ్వగానే మనం చెప్పలేం కదా ఈక్విలిబ్రియం ఎస్టాబ్లిష్ అయిందని. ఈక్విలిబ్రియం ఎస్టాబ్లిష్మెంట్ గురించి చెప్పేది ఎవరినైనా ఓన్లీ దట్ ఈస్ Kc చెప్తాం. అదర్ దాన్ ద reaction that it is explained by QC. ఇంకొంచెం ముందుకెళ్ళిన తర్వాత మీకు అది చూడు. Now, what is the relation between KC and QC? Now, I am giving the need points, children, reminder. Now, so this is a extension of reaction. This is a prediction of reaction, children. This is continuation of the prediction of the reaction. This is already extend చెప్పాను కదా, ఏమనుకున్నాం మనం KC వాల్యూ హైయర్ ఉంది అనుకున్నాం. Which reaction? Forward reaction. KC వాల్యూ low ఉంటే so అంటే maximum concentration is maximum reaction is completed. Okay. Reaction hardly to proceed. Reaction is almost complete, like this things. Now, so one more side is required. This is a prediction of reaction. Prediction of reaction. Of course. Right. Already I told you now, KC value is greater. Reaction is almost completed. KC value is low, hardly to proceed. In between the measurable means almost equal, and this is both are same, similar, stable, like at middle concentration lo untai reactant and product. Extension of the reaction ante now it will be moved to forward reaction or backward reaction. It will shift avali. That can be explained by QC and KC. But I am taking, children, the first one, concept by concept for neat points. QC is greater than KC. Okay. Reaction backward is favorable. If QC is less than KC, reaction forward shifting is favorable. Now, QC is equal to KC, then reaction at equilibrium. At equilibrium. It's clear, children. Let me discuss now by using these diagrams. Chudandi. First, what I am taking, children, QC is less than KC. This is first. Right? So here, this is a QC, this is a KC. Now, next. Again, right, this is a QC, this is a KC. Now again, Swani, చెప్పి మొత్తం క్లీన్ చేయాలి, మొత్తం డస్ట్ క్రాస్ చేస్తావా? It's clear, children. This is again QC, and this is Kc. Now QC2, okay na, ఇది decrease అవ్వాలి కదా తల్లి, ఏమవుతుంది నీకు backward reaction. Okay, right here QC is greater than Kc, backward reaction will favor. Kc is greater than QC, forward reaction will favor. Children, is clear na?
Yes, sir.
Whenever QC Kc values are the given below, for example మీ Kc value ఇచ్చారు, QC value కూడా ఇచ్చారు, రియాక్షన్ ని ఎటువైపు ఎక్స్టెండ్ అవుతుందో చెప్పు అంటాడు. Based on this concept, I am giving the one more problem, children, for understanding of this concept. Okay, ma. So children, this is a QC value. QC means reaction coefficient. Reaction coefficient. Now, reaction coefficient is that it is the ratio of the product of active mass of products to reactant. Okay, na? Any time of the reaction other than equilibrium state. Equilibrium state lo kaakunda ekkada gaani ide concentration ki ratio తీసేసుకుంటే that it is called as a reaction quotient. Okay, now if in case at equilibrium consider chesthe untumnana, this is a Kc antam, this is called as a Kc. What will be happening, children? First, so this is a Kc value is greater, Kc value is greater means this value is greater than that of this one, this one. Now which reaction, now product concentration, okay na, is maximum. Kc value is maximum, product concentration is maximum. అంటే మనం ఎక్స్పెక్ట్ చేసిన దానికంటే హైయర్ ఉంది కాబట్టి which reaction will be favored? Backward reaction will be favored. So QC is greater than, QC is less than Kc, so forward reaction means ఇక్కడ చూడండి QC is greater than Kc. ఇక్కడ ఏమవుతుంది తల్లి, ఇక్కడ కాన్సంట్రేషన్ చూడండి, కాన్సంట్రేషన్ ఆఫ్ ది QC వాల్యూ is directly proportional to concentration of product. Kc is also product. ఇక్కడ ఏమంటున్నాం నాన్న మనం, QC is greater అంటున్నాడు. QC is greater means concentration of the product is much more greater, so that reverse reaction is favorable. Okay, ఇక్కడ ఇంకా ఏమైంది తల్లి, మనకి ఇచ్చిన కాన్సంట్రేషన్ కంటే గివెన్ వన్ అంటే Kc కాన్సంట్రేషన్ is comparatively this one and this one, okay, Kc value is greater, it will be, okay na, forward reaction, this reactant to be converted as a product. So at equilibrium, these two are at a equilibrium state, neither forward and not, this is at equilibrium. At equilibrium here, which reaction ma? Backward reaction. This case is backward reaction, this case is a forward reaction is favorable. Clear now, Varshit?
Yes, sir.
Clear. Right. I am giving the one more problem for understanding of this concept, children. Right. My problem is for a given reaction, Kc for a reaction that it is 2A is equilibrium with B and C. B and C. This is gaseous. This is also gaseous. This is also gaseous. Is 2 into 10 power minus 3. Next. At a given time of reaction, active masses of A is equals to B equals to C equals to 2 into 10 power minus 4. Okay, at a given time of reaction, active masses of A is equal to B is equal to C and was found. Okay, predict the direction of reaction. Direction of reaction. Can you solve, children, this problem? Backward reaction. Yes, very good. My solution like this. Now, QC. First, I am solving the QC. QC is equal to reaction quotient is equal to active mass of A square from the equation upon active mass of B into active mass of C. Now, this is A square, no? 2 into 10 power minus 4 into 2 into 10 power minus 4 upon, okay, 2 into 10 power minus 4 into 2 into 10 power minus 4 is equal to 1 is equal to QC. But from the question, KC is equal to 2 into 10 power minus 3. Here QC is greater than KC, no? QC is greater than KC. Is greater than KC. Then which reaction now? Children, tell me which reaction? Forward or backward?
Backward reaction.
Backward reactions.
QC is greater than KC. Backward reaction is backward. Clear, no? This type of model problems may appear in the DVBs also. Children, understand now? Understand now?
Yes, sir.
Yes, sir.
Yes, sir. Yes.
So,
Yes, sir. One more example.
Ashley?
You another
Now-
example problem, sir. Another example problem. You.
Now, H2 gaseous plus I2 gaseous is equilibrium with 2HI. 2HI. K is equal to, for the example 57. H2 gaseous plus Br2 gaseous to HBr gaseous. Kc is equal to 5 into 10 power 48. Now, N2 plus O2 is equilibrium with 2N1. 2N1. Kc is equal to 2 into 10 power minus 18. Based on this concept, how can you justify the extension of the reaction? Children, tell me. How can you justify the extension of reaction? By using the Kc value. Already I told you the Kc value. Children, tell me.
The 10 power just 48, sir, minus 48.
This is a 10 power 48. This is a minus 18. Kc value.
Reaction takes place very easily, sir.
Yes. So 5 into 10 power 48. Reaction almost complete. అంటే ఈక్విలిబ్రియం ఎక్కడ ఎస్టాబ్లిష్ అయిందన్న ఆల్మోస్ట్ ఎండ్ ఆఫ్ ది రియాక్షన్ లో ఈక్విలిబ్రియం ఎస్టాబ్లిష్ అయింది, ఆల్మోస్ట్ కంప్లీట్. దిస్ ఈస్ హార్డ్లీ టు ప్రొసీడ్. This is almost at equilibrium. Concentration of R almost equals to product. It's clear. Okay, understand my concept. Ma, tell me. It's clear. Clear now?
Yes, sir.
Right, children. So these are the applications of the KC by using the stability, extension, and prediction of the chemical reaction. It's clear. Now let me move to the another important topic, most important for me, that it is factors affecting the equilibrium state. Factors affecting equilibrium state. Reminder children, equilibrium concentration constant means K does not affected by the concentration, temperature, volume, but equilibrium should be affected. Right children? So C. Brown and Lee Chatelier, the scientists whose name is C. Brown and Lee Chatelier, conducted the lot of experiments over the equilibrium system and gave a law or principle that it is called as a Lee Chatelier principle. Lee Chatelier principle. Then what is a Lee Chatelier principle? Okay. Here students, for the example, what I am taking children, this is a spring. So normal spring is hang like this. But what I did a 1 kilogram bar is attached to this 1 kg. If we attach it to this one, immediately spring will be stretch and again will come back and again stretch, will come back and again stretch, will come back and exist at equilibrium state. After ఇది యాడ్ అయిన తర్వాత మళ్ళీ ఒక పర్టికులర్ ప్లేస్కి వచ్చిన తర్వాత ఇది కాన్స్టెంట్ గా అలాగే ఉంటుంది. నువ్వు 2 years తర్వాత చూసినా కానీ అదే హైట్ లో ఉంటుంది, హైట్ ఏమి చేంజ్ అవ్వదు. ఓకే, so means this is the equilibrium is established between the gravitational forces and intermolecular forces of the tensile strength of this spring. Both are in equilibrium state. Like this, any way of this one, ఏదైనా ఇప్పుడు ఏం చేసాం తల్లి, ఏదైనా ఒక సిస్టమ్ at equilibrium state లో ఉంటే, if we disturb that equilibrium state, the equilibrium regains, means it shifts towards the change is nullified or reduced. నువ్వు ఏదైతే చేస్తున్నావో ఆ ఫోర్స్ ని మినిమైజ్ చేస్తుంది. That it is Lee Chatelier principle. Now I am writing the Lee Chatelier principle first.
So once can I explain the
Lee Chatelier principle, na?
Yes, sir.
Lee Chatelier principle. Yes. I am taking more examples for explanation of this one. Stay in the class. Now, if a system at equilibrium state equilibrium state is subjected to change in concentration, comma, temperature and pressure. The equilibrium shifts in the direction of the change is nullified or reduced. It's clear, children, what will be happening? నువ్వేదో చేంజ్ తీసుకొచ్చావు, ఆ చేంజ్ ఏమవ్వాలి? నలిఫై అయ్యే వైపుకి ఈక్విలిబ్రియం షిఫ్ట్ అవుతుంది. దట్ ఇట్ ఈస్ కాల్డ్ యాజ్ లీ చాడ్లర్ ప్రిన్సిపల్. నువ్వు కాన్సంట్రేషన్ ఇంక్రీజ్ చేసావనుకోరా, ఇఫ్ యూ ఇంక్రీజ్ ద కాన్సంట్రేషన్, ఇట్స్ కాన్సంట్రేషన్ విల్ బి డిక్రీజ్. నువ్వు కాన్సంట్రేషన్ ఇంక్రీజ్ చేస్తే కాన్సంట్రేషన్ డిక్రీజ్ అయ్యే వైపుకి ఈక్విలిబ్రియం షిఫ్ట్ అవుతుంది. టెంపరేచర్ ఇంక్రీజ్ చేస్తే టువర్డ్స్ డిక్రీజ్ ద టెంపరేచర్, లైక్ దిస్. నువ్వు ఏదైతే నువ్వు సోర్స్ ని అప్లై చేస్తున్నావో ఆ ఫోర్స్ మినిమై అయ్యే వైపుకి ఈక్విలిబ్రియం స్టేట్ షిఫ్ట్ అవుతుంది. దట్ ఇట్ ఈస్ కాల్డ్ యాజ్ లీ చాడ్లర్ ప్రిన్సిపల్. ఫర్ ది ఎగ్జాంపుల్ ఐ am taking, children, the following factors that affecting the equilibrium state. The following factors that affecting equilibrium state, right? So that first one, is a concentration. Second one is a temperature. Third one is a pressure. Fourth one is a catalyst. Fifth one is a addition of inert gas. Banu, tell me, what did you understand the Lee Chaudhary principle? Banu, tell me, what did you understand the concept of
Definition, sir.
What did you understand?
State is subjected to change concentration, temperature, and pressure. The equilibrium shifts in the direction of change.
Yes. Okay, na? The equilibrium shifts in the direction of the change is nullified or reduced. And కొంచెం ఎక్స్ప్లెనేషన్ వచ్చేసిన తర్వాత ఈ డెఫినేషన్ డీప్ లోకి వెళ్ళిపోతుంది. అంటే హౌ టు వీఆర్ యూజింగ్ దిస్ లీ చాడ్లర్ ప్రిన్సిపల్ లైక్ దిస్. చూద్దాం తల్లి. ఫస్ట్ ఎఫెక్ట్ ఆఫ్ కాన్సంట్రేషన్. లెట్ మీ డిస్కస్ నౌ. ఎఫెక్ట్ ఆఫ్ కాన్సంట్రేషన్. Effect of concentration. For the example I am taking, A is equilibrium with B. Equilibrium establishing. Suddenly, this is 1 mole kada. I am adding the A. Adding the A means if I increase the concentration of reactant concentration increases. మనం ఇంక్రీజ్ చేసిన కాన్సంట్రేషన్ ఆఫ్ ది రియాక్టెంట్ విల్ బి డిక్రీజ్ ఇన్. నువ్వు కాన్సంట్రేషన్ ఇంక్రీజ్ చేసినావు కదా, ఈక్విలిబ్రియం ఎటువైపు షిఫ్ట్ అవుతుంది? నువ్వు ఇంక్రీజ్ చేసిన కాన్సంట్రేషన్ డిక్రీజ్ అయ్యే వైపు. Decrease అవ్వాలి అంటే reactant to be converts as a product. Such reaction is called as forward reaction is favor. Children, once again I am explaining. Listen carefully. Okay. If you are increase the concentration of the reactant concentration ని increase చేస్తున్నావు. ఈక్విలిబ్రియం ఇట్ సెల్ఫ్ ఏమవుతుంది తల్లి, నువ్వు ఏదైతే చేంజ్ చేస్తున్నావో ఆ చేంజ్ ఏమవ్వాలి, ఇట్ షుడ్ బి నలిఫైడ్. If you are increase the concentration of the reactant concentration increase చేస్తున్నావు. నువ్వు ఇంక్రీజ్ చేసిన కాన్సన్ట్రేషన్ ఏమవ్వాలన్నా డిక్రీజ్ అయ్యే వైపుకి షిఫ్ట్ అవుతుంది. ఇట్స్ కాన్సన్ట్రేషన్ డిక్రీజ్ అవ్వాలి అంటే విచ్ రియాక్షన్ టు బి టేక్స్ ప్లేస్, ఫార్వర్డ్ రియాక్షన్ టు బి టేక్స్ ప్లేస్. ఇట్స్ క్లియర్. ఫస్ట్ కేస్ కంప్లీటెడ్. ఇట్స్ క్లియర్ నా చిల్డ్రన్?
Clear, sir.
Yes, sir.
మా B Kirtana is in the class. Bellam. OMR number 249, last 3 digits. I think లేదనుకుంటున్నాను క్లాస్. ఒకసారి తనతో మాట్లాడాలి నేను. ఆ క్లాస్ అయిపోయిన తర్వాత ఒకసారి మాట్లాడాలి. రైట్. తర్వాత right children, again what I am taking for the example, this is a reactant concentration changes em jarugutundo telusukundamu. Now what I am doing here, just I am decrease the concentration of this B means product concentration decrease చేశాను. ఏం అవ్వాలి, నువ్వు డిక్రీజ్ చేసిన కాన్సంట్రేషన్ ఇంక్రీజ్ అవ్వాలి అంటే ఇట్స్ కాన్సంట్రేషన్ విల్ బి ఇంక్రీజ్డ్. ఇట్స్ కాన్సంట్రేషన్ విల్ ఇంక్రీజ్డ్ అంటే ఇది కాన్సంట్రేషన్ ఇంక్రీజ్ అవ్వాలంటే ఇది ఫామ్ అవ్వాలి. ప్రోడక్ట్ ఫామ్ అయ్యే రియాక్షన్ ఏ రియాక్షన్ అన్నా టెల్ మీ, ఫార్వర్డ్ ఆర్ బ్యాక్వర్డ్?
Forward reaction.
Forward reaction. Now first case 1, if concentration of reactant okay na increase or concentration of product decrease, forward reaction is favorable. Children, it's clear na?
Yes, sir.
Varshit, understand the concept? Varshit, clear? ఇప్పుడు దీనికి ఒక ఎగ్జాంపుల్ ఇస్తున్నా చూడండి తల్లి. ఎగ్జాంపుల్ వాట్ ఐఎమ్ గివింగ్. For this following equilibrium state, to the following from the following equilibrium state, okay, a little amount of NH3 is removed. What will be happen? So equilibrium state is N2 plus 3H2 is equilibrium with 2NH3. This is gaseous. This is also gaseous. This is also gaseous. What will be happening, children? Tell me, what is your answer? ఏమవుతుంది ఇప్పుడు దీని కాన్సంట్రేషన్ అంటే లిటిల్ అమౌంట్ మనం దీన్ని రిమూవ్ చేసినాం ఈ ఈక్విలిబ్రియం స్టేట్ నుంచి ఏమవుతుంది చెప్పండి వెరీ గుడ్ ఫార్వర్డ్ రియాక్షన్ ఈజ్ ఫేవరబుల్ ఎఫ్ఆర్ ఫార్వర్డ్ రియాక్షన్ ఈజ్ ఫేవరబుల్ that it is more NH3 will form. Children, it's clear na?
Yes, sir.
Alright. Okay. Then going to the next concept, what will be happening? If again చూడండి, again I am taking the A is equilibrium with B. A concentration I am decreasing. నేను A concentration ని డిక్రీజ్ చేశాను. A concentration డిక్రీజ్ చేస్తే ఏమవుతుంది తల్లి? A concentration ఇంక్రీజ్ అవ్వాలి. మనం ఏదైతే చేస్తున్నామో అది నలిఫై అవ్వాలి. అంటే కాన్సన్ట్రేషన్ డిక్రీజ్ చేసామనుకో ఇమీడియట్లీ ఇట్స్ కాన్సన్ట్రేషన్ ఇంక్రీజ్ అయిపోయి మళ్ళీ బ్యాలెన్స్ అవ్వాలి. ఓకే, సో ఇట్స్ కాన్సన్ట్రేషన్ ఇంక్రీజ్ అంటే ఇట్ విల్ బి ఫార్మ్. ఇది ఫార్మ్ అవ్వాలి. ఇది ఫార్మ్ అవ్వాలంటే విచ్ రియాక్షన్?
Backward reaction.
అంటే రియాక్టెంట్ కాన్సన్ట్రేషన్ డిక్రీజ్, బ్యాక్వర్డ్ రియాక్షన్ ఇస్ ఫేవరబుల్. Now I am increasing the concentration of B concentration increase చేస్తాం. మనం ఇంక్రీజ్ చేసిన కాన్సన్ట్రేషన్ ఏమవ్వాలన్నా డిక్రీజ్ అవ్వాలి. డిక్రీజ్ అవ్వాలంటే ఇట్ విల్ బి కన్వర్ట్స్ యాజ్ A. This is also favor backward reaction. So that decrease the concentration of reactant or increase the concentration of product, backward reaction is favorable. Simple. Increase concentration of product or decrease concentration of reactant, that implies backward reaction is favorable. Varshit, understand na?
Yes, sir. Understood, sir.
So what will be happening when N2 or 2 moles of hydrogen is removed from this reaction? ఈ రియాక్షన్ నుంచి 2 moles హైడ్రోజన్ ని రిమూవ్ చేసినాం. ఏమవుతుంది?
More hydrogen is produced.
మోర్ హైడ్రోజన్ ప్రొడ్యూస్ అవ్వాలంటే విచ్ రియాక్షన్? బ్యాక్వర్డ్ ఆర్ ఫార్వర్డ్?
Backward reaction.
It's clear. Backward. My concept understand na? My concept children?
Yes, sir.
Okay. Right. Now going to the Satvika na? Satvika.
Meghana, sir.
Huh? Is it Satvika?
Meghana, sir.
Meghna. Okay. Meghna. Right, children. So this is the effect of concentration is completed. Now, let me go to the effect of temperature. Effect of temperature. What will be happening, children? How the temperature will affect the equilibrium state? Let me discuss. Right. Now I am taking the similar example, the previous like this previous example, children. Okay. I am taking this is right. This is a is equilibrium with B. Of course, this is a exothermic or endothermic, whatever delta H is, for the example, negative. No, first positive తీసేసుకుంటున్నాను. రిమైండర్ చిల్డ్రన్ ఎప్పుడైనా గుర్తుంచుకోండి, ఫార్వర్డ్ రియాక్షన్ ఎండోథర్మిక్ అయితే బ్యాక్వర్డ్ రియాక్షన్ ఎగ్జోథర్మిక్ అవుతుంది. ఆర్ ఫార్వర్డ్ రియాక్షన్ ఎగ్జోథర్మిక్ అయితే ఇట్స్ రివర్స్ రియాక్షన్ విల్ బి ఎండోథర్మిక్ అవుతుంది. రిమైండర్. నౌ చిల్డ్రన్ అంతా తీసుకోండి. ఫర్ దిస్ రియాక్షన్ ఈజ్ ఇట్ ఇన్ క్లోజ్డ్ వెసల్, it is maintained at the temperature of the 425 Kelvin for the example. Now suddenly I am raising the temperature 425 to 525 Kelvin ki change chesam. Now temperature rise chesam kada, no rise chesina temperature em avvali, decrease avvali. Temperature decrease avvalante heat em avvali, absorb avvali. హీట్ అబ్జార్బ్ అవ్వాలి. హీట్ అబ్జార్బ్ అయ్యే రియాక్షన్స్ ఏమంటున్నాం మనం? ఎండోథర్మిక్ రియాక్షన్స్. మీన్స్ బై రైజింగ్ ద టెంపరేచర్ endothermic reactions are favorable. Simply at high temperature endothermic reactions are favorable. Right. I am writing the total concept. Children, anybody doubt regarding this one? Anvita, Vasavi, Anvita.
No doubt, sir. No doubt, sir.
Right, good girl. Right, children. Observe this one. If temperature is increased, okay, increased, the equilibrium shifts towards the temperature decrease, that it is heat should be decrease, means adsorbed. Heat should be adsorbed. That it is endothermic reaction. Endothermic reaction. Abdur children, I am giving the statement. This is simply SPP, special point. Okay, at a high temperature or a higher temperature. Okay, endothermic reactions are more favorable. Children, it's clear na? Ma, anybody doubt?
Yes, sir.
Doubt? No doubt.
No doubt, sir.
No doubts. Sir, 1 minute, sir. Last point.
The previous page.
Shirendra. It is also there now. My God. Painful. Clear?
1 minute. Completed, sir.
Right. Right. Now going to the temperature decrease. Okay. The discussion regarding with temperature decreased. ఇప్పుడు చూడండి again A is equilibrium with B. టెంపరేచర్ ఏం చేసాం నాన్న మనం టెంపరేచర్ ని డిక్రీజ్ చేసాం. డిక్రీజ్ అయిన టెంపరేచర్ ఏమవ్వాలి తల్లి? ఇట్ షుడ్ బి ఇంక్రీజ్. సో టెంపరేచర్ షుడ్ బి increased means heat should be liberated. Heat should be liberated. So heat liberated reactions are called as exothermic reactions. Temperature decrease means low temperature. At low temperature, exothermic reactions are favorable. Children, it's clear now? Clear now? Ma, unmute please.
Clear.
Yes, sir.
If temperature is decreased, the equilibrium shifts towards the temperature increase. That it is heat should be released. That it is exothermic reaction. So special point for consideration this is, right children? Special point. At a low temperature,
Exothermic reactions are more favorable.
yes, exothermic reactions are favorable. It's clear now?
Clear, sir.
Yes, sir.
My question is, among following in which equilibrium state forward reaction is more favorable by rising temperature. First one, N2 gaseous plus O2 gaseous 2NO gaseous. For this reaction, delta H is positive. Second one, H2 plus I2 is equilibrium with 2HI. Delta H is negative. Next, N2 plus 3H2 is equilibrium with 2NH3 plus 92 kilojoules. Last option. CaCO3 is equilibrium with okay. H2 plus O2 is equilibrium with 2HO plus 245 kilojoules.
Option A,
Right.
sir.
Huh?
Option 1, sir.
Option A, sir.
Option A, right.
Yes, sir. Option 1.
So option A is endothermic reaction. Endothermic reaction. Endothermic reactions are okay more favorable at okay. Endothermic reactions are more favorable at okay na high temperature. It's clear, right? So our answer is this one. Clear now, Banu?
Clear, sir.
Right. Let me discuss. Then going to the next concept. Now pressure. How it is affect the pressure. Let me discuss. Now continuation of this one. Effect of pressure. Effect of pressure. Conditions what I am giving. First conditions. Delta Ng is equal to 0. No effect. By changing the pressure, no effect. Whatever, if you increase the pressure, decrease the pressure, equilibrium neither shifts towards forward nor shifts towards backward whenever delta N is equal to 0. Okay. If in case delta N of gaseous is not equals to 0 at constant pressure, two conditions. At constant pressure, constant volume. Constant volume. This is constant pressure. Now again, whenever going to this one at constant volume, no effect. No effect by changing the pressure. Okay, by changing, no effect on equilibrium state by changing pressure. Now delta N is not equals to 0 now. Delta N is not equals to 0. Delta N is not equals to 0. In that situation, children, delta N is not equals to 0, right? It may be negative or positive. Delta N value less than 0 or greater than 0 is not equals to 0 means two cases is there now. Two cases is there. Okay, again, delta N value. Okay. So delta Ng greater than 0 means positive. Delta Ng less than 0 means negative. What will be happening, children? Okkate concept, simple concept. Concept ke concept, simple concept. Ee concept ante denikana answer cheyochu. Simple. My special point is simple. As increase the pressure, the equilibrium shifts in the direction of the number of moles or volumes increased. As increase pressure, the equilibrium shifts. The equilibrium shifts in the direction of number of moles. Okay, number of moles or volumes decrease, and vice versa. If pressure decreased, the equilibrium shifts in the direction of number of moles increased. Anvita, clear now? Anvita,
Yes, sir.
if pressure decrease, equilibrium shifts towards number of moles or volumes increase. It's clear. ఈ కాన్సెప్ట్ మీ దగ్గర బేసికల్ గా తీసేసుకుంటే మీరు దేనికైనా అప్లై చేసుకోవచ్చు. ఇట్స్ వెరీ యూస్ఫుల్ కాన్సెప్ట్. నౌ లెట్ మీ టేక్ వన్ మోర్ ఎగ్జాంపుల్. Delta n is positive. What I am taking this is for the example PCl5 is the equilibrium with PCl3 plus Cl2, all are in gas phase. Here delta n is greater than 0, nothing but positive. 2 minus 1 is equal to 1. Okay. ప్రెజర్ ఇంక్రీజ్ చేస్తే నంబర్ ఆఫ్ మోల్స్ డిక్రీజ్ అయ్యే వైపు, అంటే ఇక్కడ ప్రెజర్ ఇంక్రీజ్ చేసామనుకున్నాను, నంబర్ ఆఫ్ మోల్స్ డిక్రీజింగ్ సైడ్ మీన్స్ హియర్ బ్యాక్వర్డ్. సో వెన్ ఎవర్ డెల్టా ఎన్ is greater than 0 is nothing but positive. Okay, no? If pressure increase, which reaction pressure increased? Which reaction? Backward reaction is favorable. In case of this one, what I am taking, children, this one, delta n means n2 plus 3H2 is equilibrium with 2NH3. All are in gaseous state, of course. Now delta n is negative now. Negative. Now if pressure increase, equilibrium should be shifts in the direction of number of moles decrease. So number of moles, this is 1 plus 3 moles, 4 moles, this is 2 moles towards forward. Pressure increase. Okay. Then delta n is negative. Forward reaction is favorable. It's clear now?
No, sir.
Huh? Understand or not understand?
No, sir.
No. Right. Once again, I am taking, children, this is a, okay. I am taking the N2 plus 3 moles of H2 is equilibrium with 2NH3. This system equilibrium lo undi talli maniki. This system is a equilibrium system. ఇప్పుడు నేను ప్రెషర్ ఏం చేస్తున్నా, ప్రెషర్ ఇంక్రీజ్ చేస్తున్నా. కాన్సెప్ట్ ఏం చెప్పాను తల్లి, యాజ్ ఇంక్రీజ్ ప్రెషర్ ద ఈక్విలిబ్రియం షిఫ్ట్స్ ఇన్ ద డైరెక్షన్ ఆఫ్ నంబర్ ఆఫ్ మోల్స్ ఆర్ వాల్యూమ్స్ డిక్రీజ్. ఇది ఎన్ని మోల్స్ ఉంది నాన్న? దిస్ ఇస్ 1 mole, దిస్ ఇస్ 1 mole. రియాక్టెంట్ సైడ్ హౌ మెనీ మోల్స్? 4 moles. ఇన్ టువర్డ్స్ ప్రోడక్ట్ సైడ్ హౌ మెనీ మోల్స్? 2 moles. 4 volume, 2 volume. Pressure increase, number of volumes decreasing side, favorable. So reactant to product means forward reaction is favorable. Clear now, Varshit?
Yes, sir.
Now for this system pressure decrease చేసామనుకో ఏమవుతుంది?
2 to 4, sir.
2 to 4.
Backward reaction.
Yes. Backward reaction. Pressure decrease, pressure increase. Children, anybody doubt? Children, tell me, anybody doubt? సో ఇక మీకు డెల్టా ఎన్జీ గుర్తుంచుకోవడం డిఫికల్టీ ఉందంటే మీరు దీని నుంచి వెళ్ళిపోండి. యాజ్ ఇంక్రీజ్ ద ప్రెజర్ ద ఈక్విలిబ్రియం షిఫ్ట్స్ ద టువర్డ్స్ నంబర్ ఆఫ్ మోల్స్ విల్ డిక్రీజ్. దట్స్ క్లియర్, వెరీ ఈజీ. రైట్ చిల్డ్రన్? ఓకేనా? ఓకేనా? Right children, this is our class for today. Next we will meet with a new class and continuation of this Lee-Chatler principle and industrial synthesis. Right children, thank you and thank you everybody. Bye to all.
Thank you, sir.
Thank you.
1
Thank you,
minute,
sir.
can you
sir.
stay for online?
Worship?
The 1 minute can you show the
Huh?
slide, right?